This is Dr.S.Prasanna, Assistant Professor of Mathematics in Pingal Government College for Women, Varangal. I am dealing with the paper Linear Algebra for BSc Mathematics Final Year, Sem 5 in CBCS system. In the previous video lesson, we have come across the concept of the column space of a matrix. We have gone through two types of definitions for it. We have seen that column A is a set consisting of the set of all linear combinations of the columns of a matrix of order m by n. This can be given in the set form like this. Column A is equal to span of a1 bar, a2 bar, so on an bar, where a1, a2, so on an are the elements of the matrix, are the column vectors of the matrix A, are the columns of the matrix A. So this is about the definition of column space of matrix, and we have seen the differences between the null A and column A also. We have solved two problems based on column space of matrix under the first model. We have taken them as Roman 1 model. Two problems we have solved, and now let us see the third problem in first Roman 1, which is the model 1 in the problems of column space of a matrix. Now the question is, find a matrix A such that W is equal to column A, where W is equal to set consisting of the vectors, column vectors with the entries B minus C, 2B plus C plus D, 5C minus D, D. That means the W consists of all the 4 by 1 column vectors of this form, where B, C, D are real numbers. Now let us solve this problem now. Given we are given with W is equal to this set consisting of the column vectors of order 4 by 1 of this form B minus C, 2B plus C plus D, 5C minus D, D, where B, C, D are real numbers. Now let us rewrite this set W so that the each arbitrary element of W can be splitted as the scalar multiplication of scalar multiples of some vectors. Here I am taking B common, C common and D common, so that we are going to get as the sum of scalar multiples of some three vectors with the scalar multiples as B, C and D. Now let us see what happens. W is equal to the set consisting of, when we take B common, the vector besides it is 1, 2, 0, 0. So this 1, 2, 0, 0 is obtained by taking B common, the coefficients of B from the arbitrary element of the set W. We can notice that B has the coefficients 1, 2, 0, 0. Similarly, take C common, and the coefficients in the element of W of C are minus 1, 1, 5, 0. Let us take them in a column vector, plus D times D. When we take D common, we get 0, 1, minus 1, 1 as the vector which consists of the coefficients of D in the arbitrary element of W. So now the set W has the form W is equal to set consisting of B times 1, 2, 0, 0 plus C times minus 1, 1, 5, 0 plus D times 0, 1, minus 1, 1, such that B, C, D belongs to the set capital R of real numbers. Now we can see that this sum of scalar multiples of three vectors by three scalars B, C, D means this is nothing but this linear combination, and for various values of B, C, D, we are going to get different linear combinations of these three vectors. That is how W now can be written as W is equal to set of all linear combinations of the vectors 1 2 0 0 minus 1 1 5 0 0 1 minus 1 1. So this set W is now written as expressed as linear combination of the three vectors. We can say that W is equal to the set called span, and W is equal to span of the set consisting of the above three vectors, above three column vectors. So W is equal to span of the set consisting of 1 2 0 0 minus 1 1 5 0 0 1 minus 1 1. Now let us consider a matrix A with these three column vectors as the three columns in that matrix. So if we take these three column vectors in the set span as columns of a matrix, that matrix obtained, we are naming it as the matrix A. So A is equal to 1 2 0 0 is its first column, minus 1 1 5 0 is its second column, 0 1 minus 1 1 is its third column. So that this matrix A is of order 4 by 3. It has 4 rows and 3 columns. Then if we write these column vectors as columns and form a matrix A, then W will now be equal to column space of matrix A. That means W is equal to column A, COL capital A. That is, W is nothing but the set of all linear combinations of columns of A. If A is such a matrix, all the set of all the linear combinations of these columns of matrix A form the set W. So therefore W is equal to column A for the matrix A is equal to, when I read it by columns, it is 1 2 0 0 minus 1 1 5 0 0 1 minus 1 1. So this is the last problem under first model which we have considered under Roman 1. Now let us move on to the next model of the problems and in the column space of a matrix A, and here also there are some problems. First let us see the first problem under this Roman 2 second model. So first question is, let A is equal to, if I read them by column wise, 7 minus 2 0 minus 5 minus 2 0 minus 5 7 0 5 7 minus 2, and we are asked two questions under two bits here. Let us see the questions now. First bit is, if the column space of capital A is a subspace of Rk, then what is K? What is the value of K? They are asking to find. Now the second bit is, if the null space of A is a subspace of Rk, what is K? So in both the cases we have to find the value of K, but in the first bit it is the column space of A, and in the second bit it is null space of A. So let us move to the solution now. To get the solution of this problem, we should have some point to be noted, and that point of note is, if A is an m by n matrix, then the column space of A, that is column A, is a subspace of Rm. So column space of A is always a subspace of Rm, where m is the number of rows of the given matrix A, and likewise we can say about the null space also. The null space of A, null A, is a subspace of Rn, where n is the number of columns of the matrix A. Now let us consider the matrix given in the problem, that is capital A is equal to, if we take it the column wise, if I write it column wise, it is 7 minus 2 0 minus 5 minus 2 0 minus 5 7 0 5 7 minus 2. Here we are not bothered about the entries of the matrix A. That means we are not we are not considering the elements of the matrix A. Instead, we are bothered about the order of that matrix only. And the order means what the order denotes the number of rows in that matrix and the number of columns present in that matrix. So we are considering only these two things, that is the number of rows and number of columns. That means the order of the matrix A only. Whatever be the elements of the matrix A, we are not considering them. So here A is of order 4 by 3. That means if we compare this order to m by n, we can say that m by n here is equal to 4 by 3. So that m has the value 4 and n has the value 3. Now to give the answer for the first bit, we consider the above note point and can write as the column space of A is a subspace of Rm, implies column A is a subspace of R4, as here m value is 4, that is the number of rows in the given matrix is 4, and hence by above note column A will be a subspace of R4. So to give the answer for the question as given in the problem, we have to write one more step, and it goes like this. The column space of A is a subspace of Rk, and that means K should have the value 4. So the number of rows in the matrix A is 4, and with that we can say that the column space of column A is a subspace of Rm, and m takes the value 4. So if it is instead of Rm it is Rk, then K should have the value 4. And to give the answer for the second bit, we can make use of the second point of the note point above, and that is related to null space of A, and that by that we can say that the null space of A is a subspace of Rn. Here the null space of A we can say as it is a subspace of R3, because the number of columns in the given matrix A, that is denoted by small n, is equal to 3 here. So the null space of A, if it is a subspace of Rk, then K should have the value 3. So K in the second bit, the value of K should be 3. So this is how we can solve the problem under Roman 2. And here the important thing is that we have to remember this note point, which consists of two things. One is regarding column A and the other one about null A. And we have seen that column A is a subspace of Rm, where m is the number of rows of the given matrix A, and null A is a subspace of Rn, where n denotes the number of columns of the matrix A. Now moving on to the second problem of the same model. If here a matrix is given to us, if capital A is equal to, if I read them row wise, 2 4 minus 2 1 is first row, minus 2 minus 5 7 3 is the second row, 3 7 minus 8 6 is the third row. Then find K. When here also we are supposed to find the value of K, when in the first bit column A is a subspace of Rk, and in the second bit it is null A is a subspace of Rk. So let us move on to the solution of this question. First of all, we have given with a matrix A. Let us consider it A. whatever be the matrix given to us, first write it down as the first step in our solution. A is equal to 2, 4 minus 2, 1 minus 2 minus 5, 7, 3, 3, 7 minus 8, 6 row wise. And this matrix A, we can see that there are 3 rows and 4 columns. As I said earlier in the previous problem, we are not concerned with the elements or entries of the matrix A, and we are only bothered about the number of rows and number of columns present in this matrix. So here we can observe the matrix A is of 3 rows and 4 columns. Therefore A is of order 3 by 4. We know that if A is of order m by n, then the column space column A is a subspace of Rm, and the null space null A is a subspace of Rn. I am taking the above one. Column A is a subspace of Rm as equation 1, and null A is a subspace of Rn as equation 2. Here we can observe, we can say that the matrix A is of order 3 by 4. When we compare this to m by n, we can understand m has the value 3 and n has the value 4. So here A has 3 rows and 4 columns which are denoted by m and n respectively. Hence m is equal to 3 and n is equal to 4. Now applying above note point, that means above the mentioned point, we can say that column A, we can give the answers for first and second bits. In the first bit, the column A is a subspace of R3 because column A is a subspace of Rm, and here by equation 1 the column A is a subspace of Rm, and here we have the value of m as 3. Therefore we can say that column A is a subspace of R3 by above equation 1. And here if we take it in terms of K, we can say that column A is a subspace of Rk for K is equal to 3. Therefore K is equal to 3. Therefore the value of K in the first bit, which is wherein we need to find the value of K when column A is a subspace of Rk. Here the value of K is 3. And moving on to the second bit, null A is a subspace of Rn by equation 2. Now applying that equation 2, we can say that null A is a subspace of R4. And as here the number of columns in the matrix A are 4, because the number of columns in matrix A are denoted by n, is denoted by n, and that n here is equal to 4. Therefore null A is a subspace of R4 by equation 2. Now null A is a subspace of Rk, means K should have the value 4. Therefore here also the value of K, we can say it is 4 here. So in the first bit we got the answer for K as 3, and in the second bit we got the answer for K as 4. So this is the solution for second problem, and this is the problem under second model of the column space of a matrix. Now let us move on to the next problem, that is if A is equal to 4, 5 minus 2, 6, 0, that is the first row of the matrix, and 1, 1, 0, 1, 0, this is the second row of the matrix. Now we are asked to find K when column A is a subspace of Rk and null A is a subspace of Rk. So reading this problem, now going through this problem, we can understand that this is also the same model as the previous two problems. Here also we need to find the value of K when column A is a subspace of Rk and null A is a subspace of Rk. And let us move on to the solution. To give the solution now, we are given with a matrix A that is having 2 rows and 5 columns, and let us consider and write it as our first step in the solution. Capital A is equal to 4, 5, minus 2, 6, 0 is our first row, and 1, 1, 0, 1, 0 is the second row of the matrix. So capital A is given like this. Here, whatever be the elements of the matrix A, we are concerned only about its order. The order of the matrix is the point of concern to get the solution of this problem. So here A is of order 2 by 5. We know that if A is a matrix of order m by n, then the column space column A is a subspace of Rm, and the null space null A is a subspace of Rn. Therefore, here we can say that the value of when we compare the order of the matrix 2 by 5 to m by n, then we can say that m has the value 2 and n has the value 5. So if A is a matrix of order 2 by 5, then the value of m, the number of rows in A is 2 and the number of columns in A is 5. That is how we got the values of m and n here as 2 and 5 respectively. Now, by using the point that we have mentioned just now, that column A is a subspace of Rm and null A is a subspace of Rn. Using those 2 points, we can give the solutions for the 2 bits of the problem. So first bit answer is the column space column A is a subspace of Rm. Here in this case m has the value 2. Therefore, the column space column A is a subspace of R2, and we can say that this is because the number of rows in the matrix A is 2, and that is how the column space column A is a subspace of Rm, means here it is R2. Now column A is a subspace of Rk, then K will have the value 2. So if column A is a subspace of Rk, then K should have the value 2. Therefore K is equal to 2. The null space null A is a subspace of R5. To moving on to the second bit, the solution of the second bit. The solution of the second bit depends on the point that the null space of a matrix A, that is denoted by null A, is a subspace of Rn, where n denotes the number of columns of the matrix A, and here the null space is null A is a subspace of R5 because the number of columns in the given matrix A, that is A is equal like this. Here we can say there are 5 columns. So the 5 columns denote that the value of n is 5, and hence we can say that the null space null A is a subspace of Rn, and as here it is n is equal to 5, we can say that the null space is a subspace of R5. So to give the answer to the question as given in the problem, we should write one more step, and here there it is instead of mn they have given as k. So let us see how to write the solution to the problem as given in the second bit. So for this, take null A is a subspace of Rk, and null A is a subspace of Rk means K is equal to 5. So if null A has to be a subspace of Rk, then K should take the value 5. Therefore K is equal to 5 in this case of the second bit of the problem. So now we can say that the value of K in first bit is 2 and the value of K in second bit it is 5. So that is how we can give the solution to the problem where there were 2 bits, one asking for to find the value of K when column A is a subspace of Rk, And in the second bit we were asked to find the value of k when null A is a subspace of Rk. So here we have compared the things to the node point where the column space of A is a subspace of Rm, where M denotes the number of rows of the given matrix A and N denotes the number of columns of the matrix A. So here in this problem we can say that by observing the given matrix A, we understood that M has the value 2. The number of rows in the matrix are 2 and the number of columns in the matrix are 5. And for that reason, in the first bit we got that column A is a subspace of Rk when k is equal to 2, because k should here equal to the number of rows of the matrix A. And in the second bit, the null A is a subspace of Rk when k is equal to 5, because the number of columns in the given matrix A is 5. So here it is k is equal to 5. Now moving on to the next problem. If capital A is equal to, we can say there are 2 columns or 4 rows, and if I read row wise, the matrix given A is as A is equal to 2 minus 6 is the first row, minus 1 3 is the second row, minus 4 12 is the third row, 3 minus 9 is the fourth row. Then we are asked to find the value of k when column A is a subspace of Rk and null A is a subspace of Rk. And here also it is also the same problem as in the earlier problems of this model, and here we can see we are asked to find the value of k when column A is a subspace of Rk and null A is also a subspace of Rk. The problem, if we recall, I missed to give the fourth problem, it seems. Okay, no problem. Let us go through the node point once again. If A is an m by n matrix, then the first point of the node says that the column space of capital A, the matrix A, column A denoted by column A, is a subspace of Rm, where m denotes the number of rows of the given matrix. And similarly, the null space of A, that is null A, is a subspace of Rn, where n denotes the number of columns of the matrix A. So in this we can understand that column A is a subspace of Rm and null A is a subspace of Rn, where m by n is the order of the given matrix, and m by n is the order of the given matrix, means the number of rows in the matrix A is m and the number of columns in the matrix A is n. And moving to the last problem of this model, we are given a matrix capital A like this with 4 rows and 2 columns, and we are asked to find the value of k when column A is a subspace of Rk and null A is a subspace of Rk again. And here k varies in the first bit and second bit depending on the number of rows and the number of columns of the given matrix A. So moving on to the solution now, we are given with a matrix A, and that matrix A here is equal to 2 minus 6 is the first row, minus 1 3 second row, minus 4 12 is the third row, 3 minus 9 is the fourth row. Here by this we can understand that A, the matrix A, has 4 rows and 2 columns. So as it has 4 rows and 2 columns, the order of this matrix A given can be taken as 4 by 2. So the order of the matrix here is 4 by 2. Do remember that as I said, we are not going to concern with the elements or entries of the matrix A, but we are concerned only with the number of rows and number of columns of the matrix. Whatever be the elements given in the matrix A, we are not supposed to have any concern for them. So the number of rows and the number of columns decide the value of k, which is asked in the first bit and the second bit. Now here A is of order 4 by 2, means A has 4 rows and 2 columns. So we should recall the note point again and mention it in this problem also as the next 2-3 steps, in the next steps. So this we can do like this. If capital A is an m by n matrix, then if A is an m by n matrix, then the column space of A, that is the denoted by column A, is a subspace of Rm. That means column A is a subspace of Rm, and the null space of A, null A, is a subspace of Rn. We can also see that the null space of A is a subspace of Rn. Here we should remember that the value of m in Rm is denotes the number of rows in the given matrix A, and n denotes in the Rn in Rn, n denotes the number of columns in the matrix A. So that is how, and if we know the values of m and n, we can give the value of k in the first bit and second bit. Now let us move on to give the solution. Here in this problem, there are 4 rows and 2 columns in the matrix A, and for that reason we have the value of m as 4 and the value of n as 2. Hence, now we can move on to the give the solution for the first bit and the second bit. If we see here, the column A is a subspace of Rm. So the column A is a subspace of Rm means here the column space column A is a subspace of R4, because the value of m in this problem is equal to 4. Therefore the column space of column A is a subspace of R4. Since the number of rows in the matrix A is equal to 4, and remember this point well, that the column space is always related to the number of rows in the matrix A. So column A is a subspace of Rm, where m denotes the number of rows of the matrix A. Therefore the column space column A is a subspace of R4. Therefore column A, we can say that if the column space that is denoted by column A is a subspace of Rk, then k should have the value 4, and here we can say that k is equal to 4 in the first case. In the first bit, the value of k should be 4 because there are 4 rows in the given matrix, and the column space of A is a subspace of Rk means we should understand that the value of k should be 4. Now moving on to the second bit, the null space null A is a subspace of Rn. As we know, the null A is a subspace of Rn. Rn means the n-dimensional space. What is Rm, Rn, what are all these things? Rm is m-dimensional space with entries as real numbers consisting of all the column vectors of order m by 1, and Rn means it is an n-dimensional space. Rn means Rn is a n-dimensional space with entries as column vectors of order n by 1. So and n by 1 column vectors with the elements as real numbers. So each element in the Rn in the space Rn is a column vector of order n by 1 with the elements as with the entries as real numbers. So the null space null A of this um, matrix, given matrix A, is a subspace of Rn. Rn here is equal to R2 because the number of columns of the matrix A is 2. Remember that the null space of A, that is null A, is related to, is concerned to the number of columns in the given matrix A, and here the number of columns in the given matrix A is 2, and hence the null space of A, null A, is a subspace of R2. As here the value of n is 2. But in the question there is no m and no n. They are asked us to find the value of k when null A is a subspace of Rk, and hence we should have further write the answer in another step taking Rk and write what is the value of k. Therefore, I have written the next step as null A is a subspace of Rk, and that means as in the above step the value of k should be 2. Comparing to the above step, Rk is compared to R2, so that k should have the value 2. So in the second bit the value of k should be 2. So this is the second model. I have missed one problem here. It seems the fourth problem is not there. Maybe this fifth problem is itself a fourth one. So take this fifth problem as the fourth one when you take down the notes. So all these four problems are under the second model, and we have one more model to do in this column space of matrix, and let us do them in the next video lesson. Now what we have done in the second model is that we will be given a matrix A of some order m by n matrix, then the column space column A is a subspace of Rm, and the null space of A, null A, will be a subspace of Rn. That is the note point to be remembered to solve the problems under this model 2. So this is take this as formula, even though it is note point. Learn them as formulae to do the problems in this model 2. So with this we have finished the second model of problems also in the column space of a matrix. So we have seen that in the first model we will be given some W, a set, and if W is equal to column A, we are asked to find the matrix A itself in the first model. And in the second model it is that if we are given a matrix A, we should find for what value of k that column A is a subspace of Rk, and for what value of k the null space null A is a subspace of Rk. These are the problems we are asked for in the first model and the second model. So go through the definition of column space of matrix, then matrix equation Ax bar is equal to B bar. Understand these things well. Equivalence of relations have given. Contrast between null A and column A that we have discussed in the earlier class. And then these problems. Then try to do these problems on your own. Take down the problem and try to solve the problems on your own, because there are so many numerous problems in this linear algebra. Even though every problem is very simple, you need practice to get remembered to these various methods we are applying in various problems. So do practice them very well. Thank you. I remain